Hey everyone, welcome back to chapter 2. We're going to get started. The second chapter is all about chemistry. And I did check your surveys, and some of you are a little concerned about chemistry, but don't worry, it's just basic chemistry. We're going to start with our first couple of handouts. This video is on handout 2A. And if you look at the PowerPoint, it just kind of starts off with basic atomic structure. And that's what handout 2A is all about. So I'm going to get rid of myself so I can point out some things on handout 2A, and we'll go through that in this video. So just to get started with atomic structure, I just have a few basic things. So it says atoms are made up of matter. So all atoms are made up of matter, and matter is the stuff that you see around you. So it is liquids, solids, and gases. All of those things are made of matter. Our bodies are made of matter. They're made of atoms and molecules that build the matter of our body. Number two, atoms are made mostly of empty space. So if you look at our classic picture of an atom, it's actually mostly empty space. We've got our nucleus, and then we have these electrons, and in between is a lot of empty space. Kind of interesting to think that most of the universe around us is just empty space. Number three, it says atoms are the smallest part of an element. So elements are what we find on the periodic table. Elements are types of matter that have a certain property, and atoms are the smallest part of that element. And then number four, it says we have 3 subatomic particles that build an atom. And that's what is listed here in this picture. So our 3 subatomic particles are an electron, a proton, and a neutron. And you need to know the general properties of these subatomic particles. So for example, electrons are negative, and they live in clouds that are surrounding the nucleus of the atom. Protons and neutrons are found in the nucleus. So that's what these little guys are. And it turns out that protons are positive, so they have a positive charge, which is opposite of the electrons. That's why they're attracted to one another. And then neutrons that are also found in the nucleus, they don't have any charge. So we have these 3 subatomic particles that are making up the atom, and 2 of them, protons and neutrons, are in the nucleus. 1 of them are in clouds, or sometimes they call them shells, around the nucleus. So just make sure you're familiar with the 3 different types of subatomic particles. All right. Now, I have some general information that we need to know about a typical atom. So down here it says protons distinguish one atom from another. So it's these number of protons in the nucleus that differentiate atoms of carbon, nitrogen, and oxygen, for example. So carbon has 6 protons, nitrogen has 7 protons, oxygen has 8 protons. These will never change. All carbon has 6 protons. All nitrogen atoms have 7 protons. All oxygen atoms have 8 protons. So I wrote here in green that protons can never change. If we change the number of protons, like if we have 6 protons and we add 1, look, we changed that element from carbon to nitrogen. So protons in an element never change. All right? If we change the proton, we change the atom, and that's what I have written here in blue. So these protons are super important because they're going to tell us whether we have hydrogen or helium or boron or carbon or nitrogen or oxygen or gold or silver. It's the amount of protons in a nucleus. All right, now in contrast to that, it says an atom's number of electrons and neutrons can change. So even though carbon, for example, always has 6 protons, its electrons and its neutrons may change. So written in purple here, I just say that an atom's number of electrons and neutrons may change. If we get a different number of electrons are called ions. And what they do, because electrons are negative, if we gain or lose an electron, we are going to charge that atom. So in a typical atom, protons and electrons are going to be the same number. So if I have 6 protons in an atom, I'm typically going to have 6 electrons. Because positive and negatives attract, we need 6 protons in the nucleus and 6 electrons circling the nucleus. They cancel each other out. So the overall charge of the atom is actually 0. It's not positive or negative because we have 6 positives and 6 negatives. 6 and 6 cancel each other out. But if we gain or lose an electron to make this atom called an ion, we're going to change the number of electrons. So if I add an electron, this atom is going to become negative because I'm going to have more negatives than positives. We denote this by putting a plus or a minus next to the atomic symbol. If you see a plus or a minus next to that symbol, it means that it's this ion. Ions are charged. So if I add an electron, for example, I'm going to be more negative. So we add a negative, like this is a chlorine atom with a negative sign. So that means it's a chlorine ion. And chlorine ions have a negative charge. Well, the same thing happens if we take away an electron. Let's say we lose an electron. If we lose an electron, we become more positive because now we have more protons than electrons. Remember, we can't get rid of protons. If we get rid of a proton, we change the atom. So if we're positive, it's not that we gained or lost a proton, it's that we gained or lost an electron. In the case of being positive, we're going to lose an electron. When we lose an electron, we become a positive ion. Positive ions are represented by a plus sign. So this calcium and this sodium are positive ions. They're positively charged ions. Now, it turns out that they have names for these ions, of course. So if the ion is positive, it's called a cation. If the ion is negative, we call it an anion. So if we gain or lose electrons, we form ions. It turns out that if we gain or lose neutrons, we form a different type of atom called an isotope. Now, isotopes are going to have a different number of neutrons than normal. So typically, we're going to have a basic set of neutrons in the nucleus. If those change, we form an isotope. Now, for the human body, isotopes are usually bad. They are radiation or radioactivity that can cause free radicals and make things like cancer. Ions, on the other hand, our body uses. Our body's going to use ions all the time. We'll talk about this later in different chapters. But our body doesn't really use isotopes. Having our body contain radiation or radioactivity is typically a bad thing. So isotopes are not really part of the human body, whereas we use ions all the time. So this is just kind of an introduction to the structure of an atom. So that takes care of handout 2A. And so just make sure that you know the basic structure of an atom, what the charges of protons, neutrons, and electrons are, what an ion is compared to an isotope, and then don't forget that we never change the number of protons. If we change the number of protons, we change that atom. All right, so we'll move on to the next handout, and I'll catch you later. Take care.